Alright, so it's the next day, and here we have our assembled Ender 3. But the more important part to all of this is making sure that it's properly assembled and put together. So I'll be going through all the first steps that I take when I set up a new printer. That counts from bed leveling to making sure that all the moving parts work correctly, as well as making sure that the motion systems are properly calibrated. So that means the E-steps for all of the axes here, as well as the Extruder E-steps. Obviously we're going to want to turn on the 3D printer first. And then the next thing we're going to do when it turns on is we are going to home it. Apparently the only option in this firmware that's pre-flashed with it is to home all axes at once. This is actually not the desired behavior that I was looking for. I prefer to have individual axis homing. So for bed leveling, for instance, I can guarantee that the Z-axis, the up and down, will stay on, but the other two axes will be free to move so I can level it easier. I will have a video in the future showing how to flash up-to-date Marlin firmware, customized, built from scratch. So we're not reliant on pre-existing firmware packages, either in bin format or TH3D's Marlin package is pretty good though. So I would heartily recommend that as long as you're able to understand how to customize it from there. So now that it's been homed, just take a look at how the leveling is doing. As we can see here, the nozzle is not touching the bed. So we're going to have to loosen up these 4 screws equally all the way around to make sure that at least our very first corner is close to the nozzle before we get our fine-tune level. I'm also going to begin preheating the bed and the nozzle so I can do a hot level. Leveling while heated is the best way to do leveling, since both the nozzle and the bed will expand because of the heat, making it so that it will be squished more when heated if you do a level compared to a cold bed. So you always want to do it at a hot bed when both materials are expanded to where they should be. Always try to level at the temperatures that you intend to print at. For me, that'll be about 205 degrees Celsius on this non-all-metal hot end and 60 degrees Celsius on the bed. So you can either do that by controlling the temperature individually by going to control temperature and setting the settings that way, or I prefer to set the temperatures by using the pre-configured settings in here. So I'll bump up my nozzle temperature to 285 and my bed temperature to 60 degrees. From there, hit store settings to store it to EEPROM. Go back up, go to the prepare, rotate down, preheat PLA, preheat PLA. So now you'll see that it is going to preheat to 205 degrees on the nozzle and 60 degrees for the bed. So I'll start unscrewing the screws for the bed and see if I can raise it up to meet the nozzle. Otherwise, we'll have to look for ways to lower the nozzle relative to the bed in order to make them line up in sync. I'm using the tension of the screws to figure out which corners I need to either loosen or tighten to get my bed settings just right. So I think I have a good level on this side, just not a good for printing, but a good starting leveling point. So I will move the head over, and as you can see, it's already dragging. So I will need to lower the bed by tightening the screws on this side before moving it over. Now that it's on the other side of the bed, I can begin raising it up just to where it gets close, just based on eye leveling. We'll do our final 4-point leveling with some paper once it's fully preheated, which it is about now, actually. So something that I really don't like about most lower price 3D printers is actually the fact that they use 4-point leveling. So a plane is composed of 3 points, which means that you can have 2 points on this side, say, and 1 point on this side. Those 3 points are all you need to control a flat plane. If you have 4 points, it can make it so it arcs this way, tilts this way funny, and it's really unnecessary and actually over constrains it. So say if I were to tighten all 4 of the bottom screws for this bed, I can make it so that the center point bows higher because all 4 points are bowing lower. My 3 fingers are the only thing that I need to keep this phone stable. So anywhere that my 3 fingers go, it still creates a flat plane that can control it. There's no need for a 4th point. If I remove a single point from these 3-point orientation, the phone falls. With 4 points, the phone actually doesn't gain any more stability. If I were to pull down on all 4 of these points, it actually would introduce extra stresses in the areas that are competing with one another. So if I have 3 stable points, right? So if I adjust this finger up, the other 2 fingers can adapt to it. So no matter how I reposition each one of these individual points, it doesn't affect the other 2. They can adapt and move. But if I have 4 points, like this bed does, and I raise 1 point, if I raise 1 point, the other point can't accommodate it. If this point was to remain touching, it would have to be a combination of the 3 points and adjust in the same time. The same thing is true for the bed. If you take those 2 points there and the 1 point in the back and you raise them all up, you're going to have this 4th corner here that's fighting it. It's pulling it down. But all the bed needs is 3 points to remain stable. Alright, now we're going to do our 4-point leveling. So make sure that your bed is leveled in the Z. You don't want it locked in the Z, so you want to turn your motors off, since this does not allow, at this particular time, allow you to home only one axis. So you'll need to home it and then turn the steppers off. Next, you'll want to start in whatever corner you like, just make sure it's in the corner. And you want to put a piece of paper in between the bed and the nozzle. From there, take that piece of paper and try to drag it underneath the nozzle. If the paper curls up like this, it's too tight. So, simply tighten the nut underneath until it starts sliding. So, when you begin to feel friction, but don't have it curl up like I showed before, you have the correct distance in between your bed and your nozzle. So I just like to drag it back and forth while it's free and slowly let the springs go up until I start to feel some tension. So I can feel the nozzle dragging on the piece of paper in between the bed, but it's not causing the paper to deform. This I repeat for all the way around the bed. So every corner, and then do it a couple more times, making sure to not adjust the Z-axis in any way. This one came out kind of tight, but still not deforming the paper. I would consider that acceptable, but you can choose to have it match the tension. That'll get you a more consistent leveling process. Alright, now that we're done on the Y, move it over and start on the other side. Here our nozzle's starting out a little too loose, so we'll raise the bed. The nozzle is grabbing the paper and it's a bit tighter than it was on the other side, so we'll loosen it up a little bit and lower the bed. This final corner, again, going back to the 4-point versus 3-point leveling, this one is probably going to be the corner that fights us the most, as the other ones were fairly close together, and this one is clearly super tight. So we'll do our best and try to level it as best as we can by tightening the spring and lowering the bed. There we go. That's a consistent friction. Now we're going to do it again. Alright, I can still feel the paper dragging against the nozzle, but not too tight. Aha! So, since we lowered this corner, it also lowered the entire bed, and this corner no longer touches. It's now touching again. Moving it over. Same problem. No longer touches. And our first corner got tighter again. Alright, that appears to be level. Now we'll go to loading the filament. The Ender 3 is a Bowden system. So that means that the extruder motor, this stepper motor here, has a drive gear that forces the filament down the Bowden tube, which is the white tube, into the hot end, where it gets melted and extruded onto the plate. So you need to start by loading filament into the extruder over here. To begin loading your filament, simply place your filament on the rack and carefully but firmly squeeze the handle here, feed the filament through past the gear and the idler into the base. You may need to rotate your filament based on how it goes into the port, but it should not be that hard to get into it. I needed to take this fitting off because for some reason it wasn't allowing me to slide it in. Once you have your filament inside of the Bowden tube, simply continue holding down on the arm and force it all the way to your extruder. Raise up the Z-axis so the filament has somewhere to go once it reaches the nozzle. I set mine for about 100 millimeters. Now that it's raised, I will continue manually feeding it in. There's either some binding or there's some feature on the inside of the extruder that's preventing me from manually extruding. I'm going to try a powered extruder. Make sure that the filament is actually being grabbed by the gear and pushed along into the tube. You can practice by either watching the filament enter it or by just lightly grabbing onto the filament and feeling it go in. So now that we're confident that the extruder works and that the hot end is reading a relatively close temperature so that the filament can extrude out, I like to calibrate the E-steps of the extruder just to make sure that everything else works before going back and printing the calibration tube. That way I know when I print my calibration tube, if something looks like over extrusion, it might mean that the steps for the other four directions probably are wrong or something else needs to be tuned before the extruder. The way that you calibrate E-steps is pretty simple. First, take the Bowden tube out of the hot end by pressing down on this little portion here and pulling the tube out. As you can see, watch out for a molten plastic plug here. In fairness, I completely forgot that this is not a full metal hot end, which means that the PTFE tube is actually exposed to heat, unlike most all metal hot ends where the PTFE tube sees no heat at all. So to begin the process, extrude a small amount of filament out of the end. This, you're going to cut to flush using the pair of handy dandy little snippers. Cut it as close to the base as you can and make sure that it's repeatable. So if you can place it against the end of the Bowden tube and snip, do it. Now extrude out a known amount of filament. So on my knob here, I'm going to extrude out 30 millimeters of filament. Now that we've extruded out what the computer thinks is 30 millimeters of filament, take your snippers, put it against the same point again, and cut it off, making sure not to lose the piece of filament. This will compare with a calipers or a small scale to see how much was extruded compared to how much came out. Make sure to measure from the same point cut to cut on both sides just to try to account for any irregularities that a tool like this can introduce. If possible, use a razor blade to get it as flush as possible. I'm just using this tool because it's what comes with the Ender 3. My filament extruded almost nearly exactly at 30 millimeters. Way to go, Creality. With that little bit of housekeeping taken care of, firmly reinstall your Bowden tube into the hot end, making sure that it is fully seated in there. If this is not seated, you'll get a blob and you will not get extrusion coming out. Also, this is a great time to install these little clips on the Bowden tube here and there. This locks the tube into place and prevents it from flexing in and out during retractions. With that, it's time to load up the SD card and try out the first print. The SD card was provided, for me at least, in this little USB to micro SD adapter. The SD card port is located here. Simply insert the SD card. Mine went in upside down. From the main menu, hit the Initialize TF card button. Then select Print from TF. Now, there's a whole bunch of different items that you can choose to test. So you can either choose to test the normal dog, the CRX, CR5S dual. Don't do that one, that's for dual extrusion. CR100 Lion, we probably won't do that one. And then there's a data folder which contains a lot of stuff for the computer. For now, we're going to just select Test Normal Dog. So for the first layer of the wrap, it appears that it had a hard time extruding plastic originally. This is either because of leveling issues, or there wasn't enough pressure built up in the Bowden system for it to extrude. Since it seems to be working correctly now, and there doesn't appear to be any other issues, I'm going to think that it's because there wasn't enough pressure built up in the system. This is why skirts on parts are a good idea. We'll get into that when we slice our first custom part for use later. Overall, the Ender 3 Pro appears to be a pretty competent system. It's fairly easy to set up to begin with. It doesn't require a lot of calibration, or as we saw today, it doesn't even seem to require an initial E-steps calibration, and is pretty easy for most beginners to get off going well. I am, however, anticipating a couple problems with this magnetic bed here. So, over time, the magnetism in the bed, because it's heated, will go away, especially if I heat it up to higher temperatures in order to print materials like ABS. In addition, the extruder is something that I am not also very fond of. I had a lot of problems initially inserting the filament into it, and I'm sure that some of that may be worn away as I use the machine more, but I don't think that that's healthy behavior for a new machine. When I feed in filament, it should be free and no sags, no matter how I put it in. Because hour after hour, that does add up and will cause users time after a while. Once this print completes, we'll go into slicing some new files in Cura and getting those sent over to the printer, as well as how to further calibrate your machine in case some things go wrong. A lot of common problems that I see are either related to bed leveling or they're related to missed layers. The most common reason for missed layers is something that I stressed a lot about in my assembly video, is skipping belts or loose belts. In order to print something, you're going to need to install a slicing program. A slicing program is what takes the model you've downloaded from website like Thingiverse or saved as the .stl from the modeling program and slices it up into the gradual layers that your printer will use to build your complete solid. My recommended slicer is Cura, which recently came out with version 4.0, completely overhauling the interface. Go ahead and simply search Cura, or check out the link below, to download and install the software. Once you have it installed, you'll be greeted by an initial setup wizard where you can add your printer. Simply navigate to the other section, find and select the Ender 3. Name this whatever you'd like. I will now be calling my Ender 3 Ender's Game from henceforth. Simply hit Add Printer and you'll be greeted with a blank simulated build volume of your printer. Along the top, you'll see some of the key settings you'll need to interact with to slice your models. The first is the particular printer you have, and we see that Ender's Game is still selected. Second, the filament type. We're going to be using PLA, so leave that alone for now. The third category is your specific print settings, and we'll get into more detail later. For my initial setup, Inland PLA, my PLA of choice, has a higher print temperature than the 200-degree default. So we're going to need to save a new material preset for this PLA by duplicating the generic PLA setting and changing the fields that we need. Once you've duplicated the material, select it and change the items that you want, renaming it to say which color, which brand, and any other housekeeping parameters you choose. Next, we'll alter the settings that will actually affect print quality. For my particular PLA, I'll use a default print temperature of 205 degrees and keep the other defaults for PLA the same. Print temperature, retraction distance, and speed are some of the most important things to properly tune in order to get the best looking prints. We'll be covering this later in our beginner series. Next, we'll be altering physical parameters that you want the solid to be made with. A standard layer height is 0.2 millimeters. This is the division that Cura will use to take your model and build it line by line. 0.2 millimeters seems to be a good balance between speed and detail for the 0.4 millimeter nozzle, which is the one equipped stock on the Ender 3. Next setting is infill. When the slicer creates the file, it selects a certain amount of outer layers that follow the contour of the model, called perimeters, and fills in the middle with as little or as much filaments as you'd like. Infill determines the volumetric fill of those interior hidden areas. If the part is decorative, consider 5%. For structural parts, add more perimeters and go with 50% infill. The other two selections on the screen are for supports, which are when you have parts that do not have any prior printed layers, and adhesion, which could add a raft, a brim, or a skirt. Let's go into some of the custom features that you might want to change. The first one is the wall line count, which is equivalent to the perimeters I was discussing earlier. 2 is a good start. 3 to 4 should be used for parts that are desired to be durable. You can also adjust the solid layers on the top and bottom of the model. Go for 3 as a minimum, use more if you experience pillowing or missing top layers and holes. You can also change the overall desired print speed of a part. 60 is a good maximum for the Ender 3. Slow down if you want better features. Now that we've run through these settings, let's go get a model from Thingiverse. Currently, Thingiverse's search function isn't very good. So one of my favorite tricks is to search Thingiverse through the Google page using the text box when you search Thingiverse. This works much more reliably than their internal search. We're going to download a calibration cube to make sure our dimensions are accurate once printed. Simply navigate to the page, hit the Things file, and download the .stl to somewhere you can find it. Then, all you need to do is open the file using the folder, and it'll be placed down on the bed. You can download multiple files if you choose, and manipulate them using the controllers down in the bottom left of Kira's page. After that, all you need to do is hit Slice, Review, and then save it to your SD card that you have inserted into the computer. Then you can put your SD card back in your printer. That's not so bad. Alright, so it's the next day and we have 2 options. One, we can use a tried and true method of a scraper to take it off the edge. Or, since we have the Ender Pro, we can choose to take off the magnetic backing, flex it slightly, and then move it from there. Since this is my first time with magnetic bed, let's give it a shot. Simply lift at the front flap and raise it off the magnet. The print should come with it. Now, all you need to do is simply flex the bed and the print should peel right off. See? That wasn't too hard. Now, simply reseat the bed, trying to make sure that it lines up 100% where it began the first time, so you don't have any weird overlap or underlap. I'll be using this printer as my example for all of my future guides involving bed leveling, mesh leveling, extrusion calibration, how to make your prints better, how to set up your tuner, how to set up your slicer, and pretty much anything that's desired. Hopefully this video helps out any beginner users that are just wondering, how do I get this thing to even start printing? I got it together, but now how do I get it running? If you have any questions, feel free to leave them in the comments below. If you like this and if this helped you out, leave a like, subscribe. I'm going to have lots more tips and tricks for this printer, as well as a list of upgrades that I'm already planning on. Triality has really stepped up their game with the Ender 3, and I have the Ender 3 Pro since they appear to have upgraded everything too. They made a lot of really great quality of life updates compared to the original CR10, and I'm pretty excited to give this printer another go. If nothing else, hasta la bye-bye.